This is Lindsay O'Donnell Welch with Threatpost, and I'm here today at RSA conference joined by Chris Ang with Veracode. Chris, thanks so much for joining us today. How's
Good to
your
be here.
conference been?
It's been very busy as usual, so
I'm
that's a good
sure
thing.
it's always a little crazy,
Yeah.
definitely. So, thank you so much for joining us today. I wanted to talk to you about a report that you had released back in October, and it was called The State of Software Security. And basically, it was breaking down some of the most prevalent vulnerabilities that were discovered in software, but then also looking at how those vulnerabilities were being addressed and patched, and some of the challenges around patch management for companies.
Yeah.
So just to start, there was a term that you had used in the report called security debt. And just to start, can you kind of tell us what that term means and how it relates to this report?
Yeah, I'll give you that and kind of a little bit of kind of context for the report. So security debt is kind of, if you think about it, anything that you know about in your software vulnerability-wise that you just select not to fix, that you're going to fix later, right? You can think of it like financial debt, like racking up, dollars on a credit card and then paying the minimum each month, right? You'll eventually get to paying all that down over time, but you'll pay a lot of interest. It'll cost you more. It'll be more painful. And so we see the same thing with security debt across the applications that we scan. The report is basically a consolidation of all of the customer scans that happen in our product. So tens of thousands of applications and millions of scans and over a one-year period. So we can kind of see exactly what's happening out there across different industries and so on, and what patterns are actually happening.
Yeah, that's really useful information to have, obviously.
Yeah.
So what are some of the key factors that go into security debt that you guys were specifically looking at?
Well, the picture is not the greatest in terms of what we're seeing out there. We're seeing like over half of applications are actually accumulating more security debt over time. About 25% are staying kind of flat, and then 25% are actually reducing them. And obviously that's what you want. You want to reduce it so that you get to a point where you've eliminated all the debt, and then as you go along, you're detecting new vulnerabilities along the way, but you're fixing them as they come up, right? Just again, with the financial analogies, paying down what you spend each month. And a lot of companies are struggling with the security debt for these applications that they may have been building for many years and just kind of pushing the security vulnerabilities off to the side. So what we really wanted to figure out was what are the factors that contribute to how well an organization gets after the security debt. And so we looked at a number of different areas there to try and find some correlations.
Yeah, can you go deeper into that? And
yeah, and some of these are going to seem obvious,
Right.
once you talk about them, but it's actually different to have the data behind it and kind of show that that's the case. One was just scan frequency, right? So if you're scanning your applications, once a year or once a month, that's not as good as once a day or more often than that. And so, we found the ones that are scanning more frequently, the most frequently, are fixing stuff about 3 times faster. And so the amount of security debt is not growing as much. We also found that scan cadence matters a lot. So if you imagine over the course of a year, you could be scanning on a steady cadence, like either once a day or once a week or but at some steady cadence is probably built up through some automation, and you've got some scripts to do that or whatever. And then you can imagine a different visual picture where you have this flurry of scanning, like a security sprint type activity, and then you do nothing for 6 months, and then you decide you're going to pay attention to it again, so you do this flurry of activity, and then you do nothing. And so we call that bursty. And so when you compare, when you take every application that in the whole data set and you map it against that steady versus bursty versus irregular, you find that the steady ones actually do decrease their security debt over time, and the other ones get worse. So it's not a problem that goes away immediately, right? It's a lot to deal with. It takes a lot of work to fix these coding issues. But there are these factors that can make it easier to overcome.
You also looked at vulnerabilities. cross-site scripting all the way up to, authentication and misconfigurations. So how did that kind of relate to the concept of security debt in terms of how long it was taking companies to patch certain vulnerabilities versus others?
Yeah, we had a theory that higher severity vulnerabilities, so ones that were just like had a higher impact if exploited, would be fixed, faster, and that seems reasonable. Or that higher criticality applications, like for the business that says, well, this application is like way more important business value wise than this other one. We expected that those would be fixed faster. And it turns out that you may have a little bit of speed improvement on, let's say, the higher severity versus the medium or low severity flaws, but not significantly, right?
Huh.
It wasn't nearly as impactful as the scan frequency and the scan cadence, which was interesting.
Yeah, that is.
You would just expect that intuitively to work that way, and it turns out it doesn't. And we looked at a number of factors that we thought might influence that, and it really didn't. And so, over the course, this is the 10th time we've done this report, and over the course of those years, we are continuing to see the same types of vulnerabilities crop up over and over again, right? They're not disappearing. If you looked at an individual organization, I think you'd see a downward trend. But as companies are starting to scan more and more of their software that they have, and companies are starting to do security testing that maybe have never done it before, those companies that are improving, those companies that are new, are kind of averaging each other out.
Right.
So you still see this cross-site scriptings, the SQL injections, all the issues that we've kind of known about for decades.
Well, yeah, I mean, you mentioned that this is the 10th time you've done this report. So have you noticed any sort of shifts in terms of things getting better or getting worse, or is it kind of remain the same?
You see slight declines in certain categories that, especially the ones that are, well-known, tied to breaches, SQL injection, things like that. But it's still fairly prevalent.
Right.
And again, that's partly education. It's partly some applications never having been tested before, and so they've got a lot of stuff piled up that was never addressed. So as we get better with education, as we get better with again, like better automation of scanning and incorporating it into the development life cycle, right, at all possible phases, shifting that left and actually fixing stuff before it gets so expensive to fix, I think we are going to see that get better.
Yeah, I mean, can you talk a little bit about patch management in general and the complexities and challenges that companies are facing, every day?
Yeah, well, specifically in the software space, what we see a lot of is just open source use, right? So nobody's building applications from scratch, right? They're using open source libraries for a lot of that functionality, and so you may write 10% of the code yourself, and you may be borrowing the other 90%, right, for a new application. And so when you do that, that's great. You don't have to reinvent the wheel every time, but you also inherit a lot of the risk from those open source libraries. And what typically happens is you're developing a new product, you choose those libraries, you download them, and then whatever version those libraries were on at the time, that's the ones that you stick with. And so, as you can imagine, like over time, vulnerabilities are discovered in those libraries, and so the security of those libraries gets worse and worse and worse over time. And so the patch management issue with regard to software is, well, how much risk are these libraries now introducing, and when is the right time to patch those, right? If something is announced and there's an exploit for it, I'm suddenly vulnerable today when yesterday I was fine, and I didn't make any changes to my software, right? The ecosystem just got worse. So what'll happen is companies will get further and further and further behind on those open source version patches, and the further you get behind, the harder it is to catch up, right? If you imagine going from version 1 to version 2 on something, that's a lot easier than going from version 1 to version 8, because things break along the way. And so that's the pattern you see, is this inherited risk tends to grow over time, and that is essentially another form of security debt.
Right, and that makes it even more complicated, right? Because you do have kind of, it's almost like out of your hands a little bit.
It is. Things can change underneath you without you actually doing anything, and that's the sort of the part that is hard to wrap your head around. You don't control the risk entirely. You hope that something gets patched around the same time that a vulnerability is announced, but sometimes you're just left wide open, and you have to figure out a way to kind of code around that. So it's an area we're paying a lot of attention to. The next version of the report that we're actually working on now, we're trying to drill in a lot more on the open source and the third-party stuff, and try and find some interesting tidbits that'll hopefully tell us a little bit more about what's happening there.
Were there any other key takeaways that you wanted to highlight from this previous report, especially looking into 2020?
I think really the takeaway for us is, there's been a lot of tension, I think, between DevOps and security in the past. There's a notion that, well, DevOps is trying to move so quickly, and how can they possibly do that, because where will the security happen, right? And so some security professionals that haven't really kind of caught on to how DevOps is working are a little bit afraid of what that's going to do to the safety, of their software. At the same time, you want to be able to, you want the developers to be able to create business value and like code and solve these problems confidently and put the software out there in a secure manner. So what we're finding, especially with that scan cadence and scan frequency thing, is that DevOps and security can actually coexist very nicely. And in fact, the practices that DevOps brings to software development actually are beneficial for security as well. That regularity, that automation, the feedback loops. And so if you incorporate security in the right way, DevOps is actually a great opportunity to improve the way that you're doing software security. And so I think that's the big takeaway.
No, definitely something to keep an eye on.
Yep.
So, well, Chris, thank you so much for joining us today at RSA to talk about, your report and what you're seeing in terms of vulnerabilities and how they're being addressed.
Yeah, my pleasure. Nice talking to you.
Great, thank you.